Alrighty, so I'd like to show you an example applying the binomial probability distribution. So at this point, I'm assuming that you've read the majority of Chapter 6 on discrete probability distributions and that you've probably attempted the homework assignment. But really what I want to do with this question I have in front of you is show you how you should be looking at these problems when you come across them, and the things to look for, and how to use the TI graphing calculator to help you answer these questions, because this, as you can see, the formula for the binomial distribution is very cumbersome. It's a pain in the neck to type in the calculator. As it turns out, this TI graphing calculator has this formula pre-programmed, so really all you have to know is where to look for it and how to apply it. I'm also going to help you visually see what a probability distribution looks like. And, so when you come to a question, you can look at the question, kind of read what it's saying, and kind of visualize the probability distribution, which will in turn, help you work out the problems that, the different parts that it asks you. All right, so let's give this a look. This is an insurance example. It says an insurance company has 10 policyholders who are all considered to be high risk, and the probability that one of these clients will file a major claim in the next year is 0.25. All right, so right off the bat, things that you should see and think about in terms of, like, when you're reading the question, thinking about, I guess, the information that the question gives me, like the 10 and the 0.25. Well, remember, with the binomial distribution, we use the letter N to designate the number of trials, like the total number of things that are occurring in this question. And as you can see, this the number of trials that this thing has is 10, because there's 10 policyholders. So that's my value for N. And then it gives me the probability P that someone's going to file a claim, and that is 0.25. Now remember, when you're given P, you're automatically kind of not given Q, but you should just know by common sense what Q is, because remember, P and Q have to add to 1 by the theorem of total probability. So if P, the probability of filing a claim, is 25%, then obviously the probability of not filing a claim, which is Q, that must be 75%, and we'll write that as 0.75. All right, so let's give a look at what question A is talking about, and then let's talk about what it means in terms of the actual distribution over here. I've made a table for it. So letter A says, what's the probability that exactly 2 of these policyholders will file a major claim in the next year? All right, so think about that. There's 10 policyholders. Maybe the first 2 file a claim. Maybe the first guy does and the last guy does. Maybe guys number 5 and 6 in the middle file a claim. There's a lot of ways this can happen. So remember, the binomial formula, what it does is it uses a combination and counts all the ways that the 2 people that put a claim in out of the 10, figures out how many ways can you make those 2 float in there. Then it multiplies by the probability of winning to the number of wins. Then it multiplies by the probability of losing to the number of losses. So this is the formula. Now, in terms of what's going on, now think about it. If you have 10 policyholders, over here, out of the 10 policyholders, it's a possibility that 0 of them will file a claim this year. And obviously over here, there's an associated probability. So I'm putting a 0 over here, and that probability, I don't know what that is, but maybe nobody will file a claim. Or maybe 1 person will file a claim. Or 2 people. And that's the one that this question's asking for, part A. What's the probability of 2 people? So in other words, we want this probability right here. The chances exactly 2 file a claim. But as you know, you could, maybe 3 will file a claim, or 4, 5, ... It's possible, although unlikely, maybe all 10 of them will file a claim. Again, it's possible, but unlikely that none of them will file a claim. We have an expectation as to how many should file a claim, and we know, I'd say about 25% of the 10 people. 25% of 10 people is a quarter of 10. So 10 divided by 4, it's about 2.5. I'm expecting probably around 2 or 3 people to file a claim, and look at question A is asking, exactly 2. All right, so this is the question we want to know right here. This probability, the chances that exactly 2 people file a claim. All right, so really, this exactly 2, that's the value of R. Now, R means the number of successes, the number of wins. Here, wins is a bad thing, like filing a claim. So, where, sometimes winning could be a good thing, like playing a game and winning or what have you, but this is an insurance scenario. So here, 2 people filing a claim is bad. cost the insurance company money. The people, something bad had to happen to the insured people. So here winning is a bad thing for insurance, and most of the time in insurance, winning is a bad thing. So we have x equals r. So what I'm going to do is I'm going to modify this formula right here and pop in these values. In other words, n is 10, p is 0.25, q is 0.75, and r is 2. So it's going to take me a second to modify this thing. So this is going to be a 2. That's a 10 for n. Again, r is 2. P is 0.25. R is 2. Q is 0.75. 10 and 2. So what I did was I modified the existing binomial formula that was there and substituted the values in that we have in our question. So notice the chances x takes on a value of 2 is the total number of trials, 10, choose 2, times the chances I win to the number of wins times the chances I lose. Now this expression up here, if there's 10 total trials and you take off 2 wins, that means there's 8 losses there. So probably that would be smarter. Instead of writing 10 minus 2, to save yourself some aggravation, how about you just put 8 in there? It'll make the formula look a lot nicer. All right, so now obviously we have to type this in our calculator. We don't have 10c2 worked out in our head and 0.75 to the 8th power worked out in our head. This is something you got to put into a calculator. So this is going to get us this chances of 2. So I'm going to go to our calculator and let's type this thing. Now to type 10c2, first you type the 10, hit the math key, and move over to PRB for probability, and it's option 3, NCR. So 10 NCR2 times 0.25 to the 2nd power. So I'm going to use parentheses, 0.25, close your parentheses, to the 2nd power, times, new parentheses, 0.75 to the 8th power. Close my parentheses, to the 8th power. As you can see, typing this expression, kind of cumbersome. All right, so there you have it. The calculator works this probability out to about 10 decimal places. Historically, because tables and what have you back in the days before calculators were worked out to 4 decimals, we typically round this to 4 decimal places. But don't forget, in my math lab, you have to round to whatever the directions say to round to. So I'm going to round this to 0.2816. So this thing is approximately equal to 0.2816. All right, so let's just put it out there. Obviously, that takes a little bit of time. The textbook describes, how to do this just in this fashion. What I'm trying to do is show you how to use your technology here. So, believe it or not, there is a better way to do this. I mentioned to you before that this formula for the binomial distribution is already pre-programmed in the calculator. So all you have to do is, number 1, know where it is, and number 2, know how to use it. So like anything else, it's just a matter of you see it once or twice, and then I think you'll be fine with it. So in the calculator, where this binomial function is stored, it's actually above the vars key. Now, in my calculator, it's tough to read because it's in like a light blue. If you have the TI-83, it's a yellow color. So above the vars key, it says the word DISTR, which is an abbreviation for distribution. So if you hit second vars, this is where all the probability distributions are. So if you go all the way to the bottom, and you'll see a couple of choices for the binomial distribution. One of them says binomial PDF, and the other one says binomial CDF. All right, so we're going to have to talk about what both of these do, but right now, I just want to talk about binomial PDF. All right, so binomial PDF, what do we do here? Well, you select it. Now, when you select it, you look at what's going on here. See, it's blinking. Now, the reason why it's blinking is because it wants to know, all right, you got to give me some stuff here, obviously. So what the calculator needs to know is these parameters over here, the value of n, the value of p. Believe it or not, you don't have to give it the value of q. It doesn't need it. Once you tell the calculator what p is, it knows how to get q. So you need to give it n, then p, and then the r value in that order. So I'll type it over here. This statement that we just worked out is the same as saying binom PDF of 10, comma, 0.25, which is n comma p, comma the r value of 2. Now, if in fact the statement that I just wrote here is the same as working it out with the formula, then I had better get 0.2816. So let's check it out. I'll come over to the calculator. 10. Now the comma is right here. It's above the 7 key. Get used to using the comma because you're going to use it all the time. So 10 comma 0.25 comma 2. Close your parentheses, hit enter. Notice, same exact answer. All right, so what's the point here? Well, using this binompdf operation, what does it do? It is this formula, that NCR, P to the R, Q to the N minus R. So clearly it's easier to use binompdf. So it's binompdf, N, comma P, comma R. So that's the syntax. What I'm going to do is I'm going to come over here, change this up a little bit. I'm going to paste that in there. So it's N, comma P, comma R. That's the order. You cannot mix up N, P, and R. It's expecting to see N first, then P second, then the R value third. And then notice, obviously, this thing, I'm using an equal sign here. It's approximate. I need little wiggles, obviously, but finding them in Microsoft Word is a big old pain in the neck, so I'm just going to leave it alone for now. So make sure you realize that we mean approximately 0.2816, which is about 28% probability. All right, so let's just summarize here. What did we just do? We talked about what the distribution looks like. In other words, all the things that could possibly happen for x. X could take on values starting at 0 and running all the way to 10. Question A asks for this one specific probability. So actually, I could come over to this table now and pop it in here. It's 0.2816. So as you can see, we got one of the probabilities. Now, of course, what's nice about the calculator is now, in your calculator, I may have mentioned in the past in another video, if you hit second, enter, it brings up the last thing you typed. And then say, for instance, you wanted this probability right here for 1. All you got to do is change the 2, the R value from a 2 to a 1. So what if you want to know the chances that, only one of them filed a claim? Well, you just use your arrows, go on top of the 2 right here, change it to a 1, hit enter. And now you got your next probability, 0.1877. So that'll be this probability here, 0.1877. And to be honest with you, you can get all 11 of those probabilities probably in about 30 or 40 seconds. It's a pretty fast procedure. So this binompdf feature, obviously it's key. You need to use this because it's much nicer than using the NCR, P to the R, Q to the N minus R formula. Of course you can use the formula, of course. That's how it's defined, and that's how we described it when you read the book and when you read the notes that I created for you. But, the idea here is we're looking for not only comprehension, we're looking for speed too. We're going to use the technology that we have to help us. We're not going to lean on it for a crutch, but we're going to use it to help us and speed things along so that we could really analyze problems. All right, so clearly you can sit here and hit second, enter, and start typing as many of these things as you want. You could change that 1 to a 0, for instance, and let's find the probability that nobody files a claim. Okay, 0.0563. So 0.0563. Oops, I put it in the wrong spot. Sorry, hold on. So there you go. I popped it in there for 0. And obviously, we can sit here and do all of these. Okay, fine. So let's move on and look at the next scenario. Letter B. So I'm going to slide this up a little bit. Letter B says, what is the probability that at most 3 will make a major claim? Now, let's think about this. At most 3. So that phrase, at most 3, means the most it's going to be is 3, which means it could be 3, but it could be under 3. So that statement actually is less than or equals to. So I'm going to modify my probability statement. Now, I don't want to do this one with the formula, because I think it's a mess. So what I'm going to do is I'm going to show you how to do this using technology. We'll talk about it with the formula so you can see what we're talking about here. So what I'm doing is I'm modifying the probability statement to suit this particular part of the question. Let me make this a little larger here. All right, so at most 3, which means 3 or under 3. So that's why I wrote here. The probability x is less than or equal to 3. All right, let's think about that for a second. Well, here we go. Less than or equal to 3. That means all those probabilities right there. Oops, sorry, I highlighted the wrong thing again. It's right here. All right, all these probabilities. So I don't have 3's probability yet because I didn't come over here and work it, but I could do that. So let's do that. So second enter brings up the last thing I typed. Because notice the value of n is still 10, and the value of p is still 0.25, and the value of q is still 0.75. Those don't change. What's changing is the r value, the number of wins I want, or in this case, the number of people putting in a claim. So let me change that to a 3, hit enter. All right, so this is 0.2503 approximately. 0.2503. All right, so then think about it. If I want this probability, the chances I'm less than or equal to 3, what do? Well, that's the chances I'm 3 is this number, the chances I'm 2 is that, 1 is that, and 0 is that. So the chances I'm 3 or under is obviously going to be the sum of all those probabilities. Okay, so this will equal. Now, what I'm about to do is a little bit dangerous, and I'll explain why in a second, and you'll see why. I'm pretty sure that I'm going to get an answer that's a little too rounded. And you'll see what I'm talking about in a second. And then you'll see why you should never do what I'm doing right now. So all I'm doing is adding up these probabilities. Let me give this a quick look, make sure I didn't make any typos. So 0563 1877 2816 and 2503. All right, so we got to add those. Now, I'm in Microsoft Excel over here, and it's kind of convenient. All I got to do is highlight, and well, I can just do this, equal sum. Microsoft Excel is really nice to add things quickly for us, so I'm just going to do that. And obviously, you can just punch that in a hand calculator. So I just asked Microsoft Excel to add that. I'm getting 0.7759. All right, so now, let's stop here for a second. So what I did was, I want to find the chances that I'm 3 or less, which means the phrase at most 3. All right, so we worked the probabilities for 0, 1, 2, and 3, and I took those 4 probabilities, added them together, and got 0.7759. All right, now I mentioned to you before what I think I did is a little bit dangerous. Now, what do I mean by dangerous? Well, these 4 probabilities are all rounded to 4 decimal places. You know, there was, as you can see, there are decimal places after the 4th decimal place. And in many cases, like this one here, this 2503, it was 25028. So that the values that are just past that 4th decimal place, you know, I might have an answer here, that 7759, that may be too rounded because these are 4 rounded numbers. When you have rounded answers and you use those answers to calculate other answers, that's usually bad for business, and you probably don't want to do that. We would probably want to keep these numbers to a couple of extra decimal places if I'm going to answer a question like at most 3. All right, but as it turns out, like I mentioned before, you know, we're looking for, number 1, comprehension. So I think this question in all is pretty easy to understand once you understand how to use that binomial PDF operation. But now what I'm really interested in right now is speed. Is there a faster way? Can I ask the calculator, hey, listen, just do me a favor and give me all the answers from 3 and backward? And as it turns out, there is. The calculator, if you remember, in the vars menu, had another binomial function. So if you go second, vars, and go to the bottom again where those binomial functions were, the second one was binomial CDF. Now, the P in PDF stands for probability distribution function. So the binomial probability function is what letter A is saying. Letter B is saying binomial CDF. Now, binomial CDF, the word C actually stands for cumulative. So this is the binomial cumulative distribution function. So then you're saying, what does that mean? Well, you know, the word cumulative means from the beginning. So if I tell the calculator, hey, listen, I'm going to give you a 3 right now, and I choose the CDF option, it's going to not just work out 3, but it's going to go from the beginning. In other words, in a cumulative fashion, it's going to work out from the beginning up to the number I specify, and believe it or not, it simultaneously adds all those values together. So that's obviously a very powerful calculation. Now, how do you use binomial CDF? Well, the same way you use binomial PDF. It needs N, then it needs P, then it needs R. The only difference is where binomial PDF only gives you one value in this table, one probability, binomial CDF is going to give you a chunk of probabilities from whatever number you specify backwards. So rather than do this thing, what I'll do instead, I'll use binom CDF of 10, 0.25, 3. Now, you're probably looking at that saying, well, how is that different than, the one above it when when I put a 3 in letter A, instead of like this is X is 2, and it worked out the probability of only 2. Well, when you give the CDF function a 3, what it does is it doesn't just work out 3. It works out 3, 2, 1, and none. In other words, 3 and backward, or from a cumulative standpoint, from 0 up to and including 3. All right, so let's go ahead and choose that option. Now, by the way, just one other thing. I have a TI-84, as you can see on my screen, and it's options A and B. I believe in the TI-83, I believe it's options 0 and A, because they differ a little bit, the two calculators, but the functions are the same. All right, so if I bring the let me clear this out. I want this nice and clean here. Hold on. So second vars binom CDF. So 10, 0.25. That's n, r, n, p, r, which is 3. Now again, I'm using CDF. So when I give the CDF a 3, it's not just going to work out 3. It's going to work out 3 and everything under 3. All right, let's remember before I was a little worried and I thought it was dangerous that I, used rounded answers. As you can see, it was just dumb luck that everything worked out fine for me. This 7 right here tells that 8 to bump up to a 9. So in fact, it is 0.7759. So as you can see, this feature right here in the calculator we didn't need any of these probabilities right here. So it's kind of weird when you think about that. Like the calculator gives us this answer, and we're getting an answer for the sum of those four events, those 4 probabilities summed. But yet we don't even see what those 4 probabilities are. That's the amazing thing about the calculator, where you don't need to see those probabilities. All you need is comprehension on what it's asking you. All right, so, let me pop this in here. So this is obviously 0.7759. All right, letter C. What is the probability that at least 4 of them will file a claim? All right, well, think about the phrase at least 4. Well, at least 4 means the least it's going to be is 4. So that means it could be 4 or 5 or 6, 7, 8, 9, 10. In other words, it wants all these probabilities. Let me highlight these a different color here. All right, so these probabilities in blue represent the probabilities that are, satisfying the event at least 4. Now, from a probability symbolic standpoint, if I change this, well, that's less than or equal to 3. At least is actually greater than or equal to, in this case, 4. So this statement is actually asking you, what is the probability that x is greater than or equal to 4? All right, so let's be honest. If we want, we can use that binomial PDF operation right there, and we can work out every one of those probabilities. Okay, fine. And then we can add them all up. That's great. But think about it. We already know that all the yellow probabilities here and all the blue probabilities there, we know if we add every single one of those, they have to add to the number of 1 by the theorem of total probability. So use some common sense here. Rather than work out all those blue probabilities individually and then add them up, how about, since we already know what these yellow probabilities are, and we know what all of the probabilities are, if we take the number 1 and subtract off the 0.7759, what's left over has to be for all those blue probabilities. So this must be 1 minus, for some reason it's a little low, sorry. Let me write an equals here. 1 minus 0.7759. All right, so I'll do that calculation over here. That is 0.2241 approximately. All right, so the chances that you're at least 4, which means 4 or more, find all those probabilities and add them, or use some common sense here. Now, as it turns out, you could type this statement, because think about it. What we did was 1 minus the prior answer, right? And what's the prior answer? The prior answer was a Binomial CDF operation. So actually, this statement, I'm going to pop this down here so it makes a little more sense to you. The chances I'm 4 or higher is 1 minus the chances I'm 3 or under. So that Binomial CDF of 10.253, that's that prior scenario, which when you're 3 or under. So this is actually 1 minus 0.7759, which equals 0.2241. And you could type that in your calculator exactly like this. In other words, you could start when you calculate and go 1 minus second vars, and then go find the Binomial CDF operation, 10, comma, 0.25, comma, 3. And get the answer for 4 and more in one step. Now with this statement here that I have on a calculator, which is this statement down here, what it says is, you want to be 4 and higher, take everything, which is 1, and subtract off 3 and under. So look at the picture. It's easier to see with the picture. You want to be blue, in other words, 4 and higher, take everything, which is 1. Remember, all those probabilities, blue and yellow combined, sum to 1. So 1, take off the yellow stuff, has got to get you the blue stuff. That's what this is saying. So everything, take off 3 and backwards, get you 4 and forwards. That's how you've got to view these probabilities. And that's the fast way to work them. Obviously, working using the formula. Imagine now, think about this. Go back to that formula right here, this one. You know, all this big mess right here. And use that formula, 1, 2, 3, 4, 5, 6, 7 times to get those probabilities. No way. That would take way too long, right? All right, so finally, this last question is kind of easy in the scheme of things. It asks you for the mean. I'm just going to delete this and use the symbol for mean here. It's going to dig it and find it. All right, here it is. The mean equals, well, it's a formula, n times p, which is equal to 10 times 0.25. All right, let's do that calculation over here. 10 times 10 times 0.25. All right, that's 2.5. All right, so we're expecting, don't forget what the mean represents. The mean represents the average amount. It's called the expected value, right? So another way of writing, we don't have to say mu if you don't want to. You can write EX, the expected value of X. So the expectation is that 10 times 0.25, or a quarter of 10, will be putting a claim in, about 2.5 people. And I know it doesn't ask for the variance, but what the heck? While we're here, let's just do it. So the variance, I'm going to pop it right underneath. I know it doesn't ask for variance, but while we're here, we may as well do it. So I'm going to change this to variance. I'll write var is equal to n times p times q, which is 10 times 0.25 times 0.75. All right, so that number, I've got to work that in the calculator. So that times 0.75, 1.875. All right, so let's just summarize this. The mean and variance formulas are just formulas. The mean is n times p, and the variance is n times p times q. So I got the mean, I got the variance, and don't forget, you want the standard deviation, take the square root of that variance right there. So in the calculator, I can do that in a second. So second radical, 1.875. So I'm taking the square root there. And that 1.37-ish number, That's the standard deviation for the number of claims. So, we're expecting 2.5 claims. And if, it's funny, when you go over here, everyone check it out. For X is 2, notice that probability is 0.2816, right? For 3, it's 0.2503. Notice the probabilities under that are smaller than these. These probabilities are larger than these. When you start working out 4, 5, 6, 7, ... you'll see they're lower. All these probabilities in blue are going to be smaller than these two. How come 2 and 3 have the highest probabilities? Because look, you're expecting 2.5 people to make a claim. So X is 2, X is 3. Yeah, it makes sense that those are the highest probabilities. All right, so I know this is a really lengthy video, but I hope you got something out of it. What this will really help you out with is, looking at a big, multi-part binomial question and using your technology with it to answer exactly, at most, at least questions, and then, calculating the mean, variance, and standard deviation. All right, so if you have any questions, shoot me an email. I'll be happy to answer that. Have a great day.